Welcome back to Wrench Wench Worx. I'm Jenny, and thanks for coming back to the shop. In the last video, I did an R8 spindle cartridge swap, and I had mentioned in this video I wanted to inspect the lubrication system, do a flush, and kind of figure out what that lost motion issue and why was. And I can tell you that we did do that because I'm currently shooting this intro right after I shot my outro. It's been quite an adventure. And I also mentioned while I was up on top of Oli doing this spindle cartridge swap that I really hoped I wouldn't have to mess around with that Z-axis oil manifold. Well, spoiler alert, I did. And because I'm on a pretty hot deadline right now, I've got multiple jobs going through the shop right now, a couple molds, a few prototypes. And so I kind of had to do a little creative modification to the lubrication system. Believe it or not, I'm happier with the modification that I made than the out-of-the-box lubrication system at this point. And it was nothing crazy or wild. I didn't buy anything super expensive. It was a bit of an adventure, and I had a lot of fun with it. So I don't want to make this video longer than it needs to be. So without further ado, let's just dive into this and show you what happened. All right, so I went ahead and popped off those bellow covers. First thing I noticed almost right away immediately was the y-axis ways had some buildup and some old gunky oil in it, but I didn't see any fresh oil. So I do think that this axis is starving for oil. I knew the Z-axis was going to be because I do have a severed Z-axis oil line here that I severed a few weeks ago, and so I'm going to go ahead and take care of that, patch that up as well. One other thing I noticed is you can see I have the power off, so I can rotate this freely now, but I did notice that the socket head cap screws in the coupler were marginally loose, and so we could be looking at an accumulation of several different factors. So what I'm going to go ahead and do is I am still going to pop off this table. We need to get to those oil lines, and I'll bring you along for the ride, and let's see if we can't get this oil line flushed and make sure all three axes are getting proper lubrication. Before we can remove this table, we are going to have to decouple the motor and the ball screw. And so I powered on Oli just to show you this real quick. So when we're traveling in the x-axis, you'll notice that the motor does in fact move along with the table. That is because the motor and the ball screw are coupled together, and the motor itself has a housing that is attached to the table. And so what I'm going to do is I'm going to go ahead and decouple the motor from the ball screw side. And then we're going to take this housing off as well. Once we get that all free, we should be able to just lube her up and give her a couple whacks with the hammer, and she should be free. So I'll put that on time lapse and just kind of show you guys what I'm doing. But I kind of wanted to explain that it's really important before you do anything like this to, know how the mechanics are all jointed together. So without further ado, let's whack this guy off. A few quick notes before we get started. You're going to want to go ahead and power off the machine. We do this for two reasons. First reason being safety. We're going to have our fingers in the innards of the machine. There's going to be a lot of moving parts, and you don't want the machine to take off with your fingers in any place that's going to cause them to be crushed, pinched, or forcibly detached. Second reason is with the stepper motors, when the stepper motors are energized, it is awfully hard to move this ball screw by hand. With the power off on the machine, you should be able to freely move the coupler and the ball screw by hand by just turning it. And this is going to allow you to be able to get in there with your Allen wrenches and go ahead and decouple the ball screw from the motor using your Allen keys. Other thing that we are going to want to do is remove the gib. Now you'll notice here we have what looks like a relatively large flathead screw. I have those on both sides here. What I'm going to do is remove both gib screws. And then there's this little tapered piece of metal. Now we are going to want to beat it out. And when I say beat it out, I'm not saying forcefully beat it out. We don't want to damage it in any way. But what I like to do is take a thinner piece of aluminum, a long thin piece of aluminum, and I like to tap it out from the thin side of the taper. Before I do this, I do tend to use a little shot of like PB Blaster or some kind of lubricant that really just kind of gets it nice and greasy, so when we go to slide it off, we're not fighting it in any way. But once we get that gib out, we should have a fair amount of play to this table, and once we get everything decoupled, she should just slide right off with a few gentle or semi-gentle taps. We got the table off of Oli. There's one other piece of information that I forgot to convey before we started all of this. So anytime you are removing the table, you want to make sure that on the end that you are pulling the table out from, that you have some kind of support or buffer. These tables are cast iron. They tend to be relatively heavy. And so you want to make sure that you have something to support it or to at least catch it in case you pull it off a little too easy and it kind of tips on you, because you don't want to smash your fingers and you don't want to damage the machine or the dovetail on the bottom of the table. And so you'll probably notice in the video that I had started it with nothing underneath, and then pretty soon, boom, I started adding wood. And it was one of those things that I got a little ahead of myself and just completely forgot to mention it in the last frame. Now you're probably wondering, well, are you going to remove the saddle? I'm not going to remove the Y-axis saddle, mostly because we're really focusing on oil lines here, and there's really only one oil line that goes down below there, and that's the one that feeds the ball screw. We can access all the other ones with just the X-axis table on. The reason it's also a little bit more complicated when you're taking off the saddle is both ball screws are actually attached to the saddle, and in the Y-axis, the ball screw is attached underneath, and so when you go to take that off, when you do decouple it from the motor, it'll come along out with it. And for me to pull it straight out without like potentially damaging my ball screw, I'd have to take my chip tray out, and it's just a whole lot of other complicated stuff that I really don't need to deal with right now. What I am going to do though when we do the flush is I am going to remove the Y-axis gib, and I'm going to show you too where the oil comes in through the gib, just so you can kind of get a visual. So we're still going to go through all of it. I'm just not going to go through all the extra hassle and headache of removing that saddle, just because there is a lot more involved with that. So without further ado, I am going to jump off here, give Oli a good cleaning, and we'll go through kind of the components together. I want to take a moment to draw your attention back to this Z-axis oil line, the one that had previously been severed. I did go ahead and throw a compression fitting on there, and I'm going to be making a slight modification. Because this is an old prototype machine, the layout of the previous oil line system was a little discombobulated. There were a bunch of pinch points. It kind of went up back through the casting, and it actually wove down through here on the inside of the machine. And what I'd like to do is go ahead and I'm going to route this to the back of the machine, and we're going to throw a splitter on there, and it's going to feed from the pump on this port, and the bottom port here is actually going to go ahead and feed the X and the Y axes. The reason I'm showing you this here is because there's not a ton of room back behind the machine, and I wanted to give you a good visual. But we are going to go to the bench, and I want to show you how to put on a compression fitting. Just because it's not something that everybody knows how to do, and I don't see a ton of material out there, especially when you're talking about oil lines. I snagged some fresh line, and I did jump behind the machine and just kind of double check the distance. And to be honest, that new manual pump is going to be awfully close to where that splitter is coming out. So we don't need a whole lot of line, and there's no reason to have an excessive amount of line. If anything, it's going to cause more harm than good. And so we're going to probably cut it right about here. And then we will also go ahead and add, this is just to protect the outside. And it's not really even a necessity at this point, because I'll tell you what, the oil pump is going to be back behind the machine. Nothing gets back there. I mean, except for me from time to time when I have to fix a few things, but I'm just going to go ahead and pull it back because we don't need this as long. We have to still make room for the fittings. And so I'm just going to cut it about yay. And if you take a look, we should have enough room to put fittings on both ends. So it's, again, not a necessity for what I'm doing, but this does actually kind of protect it from getting severed and from anything bad happening to the oil line. But in the meantime, we're just going to kind of go with it as is, and I'm going to go ahead and get those fittings ready. Time to throw on the fitting. Now, you probably noticed that I did go ahead and already put a fitting on this side of the oil line. I had recorded it, had intended to use that take. However, I was kind of a putz, forgot to turn off my air compressor. It kicked on while I was talking, and I may or may not have cussed a few times. And unfortunately, because I'm still developing my video edit skills, I'm not quite certain how to bleep it out. So I'm going to be looking that out later, but for now, there are two sides. And so now I can show you on this side and try to keep it somewhat family friendly. Right up here, we do have the fitting itself. Right below the fitting, we have what's called a compression nut. And the compression nut's main job is to squish this little guy right here. This little guy is called a ferrule. You'll probably notice when I flip it on its side, it is tapered on both sides. This particular ferrule is symmetric, and so it really doesn't matter which side I put on first. So the ferrule's job is basically just to prevent the line from slipping out. So I think you'll get it once we kind of go through this here. I'm going to start with the compression nut, and I'm not going to swear. There we go. So a little bit of a tight crunch, and I'm still kind of learning how to work with the video camera right in front of me. Then we're going to go ahead and push this ferrule on, and it gets just nice and snug down in there. It just kind of seats itself in the compression nut. And then we go ahead and throw this fitting on here. And now what I'm going to do is just kind of get it hand tight. And once we get it hand tight and kind of held on there, we will go ahead and grab our I just grabbed a couple adjustable wrenches. Now, you don't need to squish the ever-living goodness out of it. You just want to go about a half turn or so. Once you kind of you'll feel it when it starts compressing, and it doesn't take a whole lot. So those ferrules are quite soft. We're going to go ahead, we're going to go about like that. And that should be relatively good. So all we're doing is just kind of hugging that ferrule. And so I should be able to remove this, and we'll take a look here. So yep, that ferrule's nice and snug on there. I'm going to go ahead and give it a little trim. I did leave her just a little bit long. And there we go. So now we should be able to scooch this fitting on here, and it should line up pretty well with all the other fittings. So that's how to put on a compression fitting. Before I scrunch myself up and try to do my best contortionist impression back behind Oli while I'm plumbing in the lines, I wanted to show you this real quick. This is the manual oiler. There's nothing too spectacular about it. It's got a little filter in the bottom, a reservoir, and a handle. And when this is pressurized and all the fittings are on it, you pull the handle back and it slowly pushes oil up through the oil lines, through the manifolds, and to the little moving parts. Tonight, however, we are going to be filling it with WD-40 because I want to flush out all those manifolds. I don't think they've ever been flushed, and I did, like I said, notice that the ways were getting a little dry, and so I have a feeling there's just some old icky oil sitting in those manifolds. And what the WD-40 will do is if I flush it through the system, first of all, I'm going to be able to see if the oil lines are clear, because it should run through them if they are clear. If not, what I'm going to do is push a bunch of WD-40 through it, let it sit overnight, and see if it will break up some of the gunk So this is going to be kind of a bit of an overnight endeavor, but I wanted to show you this, kind of explain what I'm doing, and then we will go take a look in the machine once I get everything plumbed in and push through. Despite previously mentioning that I was hoping to be able to flush the oil lines at the Z-axis without having to access the manifold, as is often typical, we can't always get what we want. So here we are on top of old Ole with his spindle motor, part of his casting, and the oil manifold all removed. Now, as I was flushing the existing oil system, I noticed that the only axis that was really getting oil was the rear ways of the X-axis. So that's not good. As I started to dismantle the oil lines below, I realized that most of the flow restrictor valves were clogged, and therefore ample oil was not reaching the rest of the ways and the ball screw. Interesting note, as most of the clogging appeared to be from the Teflon tape that had disintegrated and turned into a somewhat gelatinous mess at the mouth of the valves and the seat of the manifolds. I did soak everything in mineral spirits, which cleaned it all up. However, I did decide to try a different tact if I was going to have to replumb everything anyways. Which, on a side, I did have a question for anyone out there who does have an expertise in oil fittings. As most of my career, I was under the pretense that Teflon tape should not be used in oil system fittings, as it was designed for use in air or water applications only. Now, I'm admittedly not an engineer and expert, but this did pique my curiosity, and I would absolutely love to hear if this is just common practice for single-shot manual oil systems. I did end up stripping off all the PTFE tape, and after replumbing everything and testing it out, I was delighted to find that the fittings did just fine on their own without any leaking. Now, as the native mounting position of Ole's oiler was much lower in the machine, my assumption was that the Z was not getting oil as it had gravity working against it, as well as 3 of these flow restrictor valves at the manifold. Once I got everything pulled apart, I was aghast to find that the flow restrictors at the Z manifold were clean as a whistle, looking as though they had never seen oil at all, or at least not for some time. I feel as though fate and maybe a significant layer of turkite might have been looking out for little Ole here, as the ways along the column still look to be in excellent condition. But I decided I didn't want to continue testing my luck, and I wanted to make sure, since I've gotten this far, that I would just ensure that his column and ways would be getting ample oil from this point on. Now, again, I'm not an expert on this subject by any means, so please feel free to drop a comment if I'm incorrect here. But my understanding is that flow restrictors are designed to meter or slow the flow of oil to areas of the machine that may be receiving more due to variables such as positional considerations. And if my memory serves me, and it doesn't always, but I do recall on some knee mills that I've used in the past that flow restrictors were added to the knee manifolds, but not the head, so that a disproportionate amount of lubrication did not puddle below the table due to gravity helping it out. So my curiosity did get the best of me here, and I decided to try something just a little bit different. So I went through the entire mill and actually removed all of the flow restrictor valves, replacing them with just a standard oil fitting that had a slightly reduced internal diameter. Again, definitely not encouraging this route, as I'm not an expert. I'm experimenting, but I do enjoy trying new things. And I also didn't relish the thought of spending $150 on all new flow restrictors if it was not warranted. With gravity still being a consideration, I decided to mount the manual oiler much higher up on the back of the mill, and also prepared some new oil line, adding enough length to actually create an additional loop for the oil line that dropped down below the table and the saddle components, so that all 3 axes had a bit more of a level playing field in regards to way loop flow. I bled the lines out and gave the new configuration several test runs, and I was ecstatic to find out that now all 3 axes were getting about the same amount of lubrication per pull. Now, this is a bit cobbled together, so pardon the aesthetics, though I am a lot more concerned with function over fashion. After several test runs, I'm pretty satisfied with the results. So I'm going to go ahead and run with it and keep an eye out on everything moving forward to see if this continues to work out for Oli. And I'll let you know if there are any issues in the future. All right, so I just wrapped up putting the spindle and the Z-axis lubrication system back together, and I wanted to take just a quick moment at the bench here to show you how the table and the gib interact with one another. We're going to go to the machine in just a few moments, but I figured this would be a good opportunity to give you a real good visual so that when we get to the machine, all of this starts making absolute sense to you. So you'll notice first at the bottom of the table that the geometry here is in fact dovetailed. It is dovetailed because it's going to have a gib sit alongside of here, because when you're putting the machine together, there's going to be some slack. So the machine's going to want to wibble wobble one way or the other. The gib acts as a wedge. You'll probably notice here that it's tapered. It's going to be thinner on one side and thicker on the other. As the gib sits here, you can tighten it or loosen it using the gib screws that are screwed into the machine. And so to tighten it, you would push it in so the thicker side is wedged in there a bit more. And to loosen it, you would then adjust the opposing gib screw to just kind of push it back a little and give her a little extra clearance. A couple other things you're going to notice here. The gib has kind of this mottled, rough-looking surface. That is where the gib was hand scraped. Now, hand scraping is a bit of a black art, and it's done for a couple different reasons. So typically a gib is going to be custom hand scraped to fit each particular table. And it's also done to kind of flatten it, make sure there's no high spots where it can actually start galling or pinning up on you. The other major reason that you do hand scraping is this rough looking surface, while it might not be as pretty and pristine as a ground surface, actually retains oil, which is really ideal for a sliding surface. Because if you think about it, if this was ground and you had a ground surface along here, you risk the chance of almost like ringing them or galling them together. Think about Joe blocks or gauge blocks. As you're ringing them together, it displaces the air and any oils that may be on them, and then they kind of cling together. However, because this is designed to kind of slide back and forth on the machine, you don't want those to ring together. So having that extra rough surface where the oil can kind of sit in there and act as kind of a moving lubricant is really important. You'll probably also notice that there is a hole on both sides. This one's got kind of a tract with a hole, and that is where the lubrication system feeds the oil to the gib and the dovetail here. One other note before I put it back in the machine, before I put the table back in the machine after I give her a good clean, I like to take my ruby bench stone and just run it across all those finely ground surfaces to make sure there's no peen marks, no burrs, just a real light run over the top. And if you're not familiar with the ruby bench stone, it is made by, it's made with synthetic ruby dust or crystals. And this thing is hard and fine as all heck. You can't really feel that it's an abrasive stone, even though it is. And I use mine pretty much on a daily basis, from anything from carbide tooling to finished parts. And I've had this particular one, I think about 12 years, and looks brand new. It is made of ruby, so therefore it's incredibly hard. And this particular one was made in Germany. It's double-sided. Cost for, price for a decent ruby bench stone's right around $150, but to me it's a really good investment, because as long as you take care of it and don't drop it, it pretty much lasts for darn near ever, and it makes a really good addition to your toolkit. So I just run it across these sliding surfaces as well as the gibs, just to make sure that we don't have any burrs or anything, and we should be just about ready to run into the machine and show you how all this works together. Let's start first by talking about the lubrication system, being that we put all that hard work into putting in new fittings, flushing it, and making sure that everything's running copacetically. So you'll see here this line coming in through here. This is actually coming from the oiler. This is that extra line that I looped over and gave it a little bit more gravity challenge so that it doesn't just scoot down here and only take care of the table and the saddle. So this line dumps into a manifold here, and you'll see this splits off to feed the back side of the table dovetail, and this side feeds the front side of the table dovetail. And then you'll see like this little silver line right here. You'll notice that this actually feeds right into the ball screw. And then of course over here, this side comes down. This feeds the Y-axis ball screw. And we've got another line that whips over here feeding the Y-axis left dovetail, and then this other one back here drops right into the Y-axis right side dovetail. Taking a little closer look into this X-axis dovetail here, you'll notice that here is that feeder line that feeds that back side of the dovetail for the table, and you'll probably notice there's a little hole right there. So the oil comes in through the fitting and pops out that hole, and believe it or not, that oil comes through the gib, and that's how you're actually feeding the oil into the dovetail of the table. If this is your first time seeing a machine tool with no table on it, you're probably wondering, well, gosh, Jenny, why is this top surface here green? Now, that green surface right there is actually a coating that they put on top of the metal, and it is called turkite. Turkite is very similar to like a Teflon. It's an acetal that is impregnated with bronze on most machine tools, hence why it's green. But this gives this sliding surface wear resistance and prevents the table from sticking. It also does retain oil. And you'll notice it does have oil grooves all along the top of it. Turkite is actually a saving grace for a lot of machine tools. It's relatively thick but dimensionally stable. And suppose, like in Oli's case here, you have an issue with your lubrication system, it's going to prevent the metal on the casting from wearing away. The turkite actually, again, is incredibly wear resistant and has saved many a good machine tool in the past that have been starved for oil. Last but not least, let's talk about where the gib fits in all of this. So we're currently looking at the saddle or the Y-axis, and you may notice that there's a big giant gaping hole here. Now without the gib, we're going to drive the Y-axis back and forth, and what you're probably going to notice is there's a heck of a lot of wibble wobble as it's driving around. That's because it doesn't have a gib in there to kind of hold it flush to the dovetail. And you'll also probably notice there's a little counterbore there. That is where the gib screw sits. And taking a closer look at the gib, you'll probably notice there's a notch in the front of that gib. That's where the gib head sits. So when you're pushing it in, it's actually sitting flush against here and driving it in. And on the back, you would tighten it to drive it out a little bit. So what we're going to do is I'm just going to slide it in. I'm not going to fit it right now just because this video is probably long enough for y'all. But we are going to go ahead and just throw that little gib in, and you'll probably notice it gets tighter the more you push it in. And once you kind of get it seated in there, then you would put that gib screw right in that hole, and you would just use a regular flathead screwdriver to drive it in a little. Now, when I'm adjusting gibs, it's important to note that I do like to run the machine back and forth to make sure that I'm not getting it too tight, because if I do get it too tight, the machine's going to want to stall on me. And so I tend to do my fitting kind of gradually, where I push it in a little, drive it up and down a little, and you can also throw in your indicator, do some checks to make sure that you're not losing any motion, not getting any stick slip. But that gets a lot more complicated, and I do believe that John Saunders from NYC CNC also has a pretty amazing video that's pretty in-depth on this. So I'll throw the link in the comments or in the summary for you guys. And if you have any questions, feel free to drop them into the comment section. I've got Oli all put back together with the exception of the bellow covers. When I went to put the bellow covers back on, I was taking a look at these button head cap screws, and some of them are pretty beat up. The threads are looking a little worse for their wear. So I figured tomorrow I'm going to scamper over to Ace Hardware, drop just a couple dollars, and pick up some replacement button head cap screws. Just because at the end of the day, if you do notice that your hardware does have a fair amount of wear, you just want to swap it out. Save yourself some headache in the future, because nobody wants to deal with stripped out screws or bolts the next time they turn around and have to do maintenance on their machine. Now, I realize this video is already going to be relatively long, and so I'm going to keep the ending kind of short and sweet, but I want to thank you for coming to the shop and hanging out with me here at Wrench Wench Worx. The whole purpose of a lot of these videos right now is just to show you that these machines are relatively simple in the grand scheme of things. And there's really no big mystery. There's nothing that's super complicated about them. And I want you to feel comfortable the next time you're standing behind your machine, that you're able to kind of understand if it's functioning properly, if it's not functioning properly, and just to get yourself familiar with it, because I always feel like if you understand your machine, it makes you a better machinist in the long run. So, as always, if you have any questions, concerns, comments, or feedback, please, by all means, drop it in the comments. I do try to get back to everybody as soon as I can. If you like what you're seeing, go ahead and give that a thumbs up. Otherwise, if you want to see more of me, feel free to subscribe. You're also welcome to drop me an email anytime at wrenchwenchworx@gmail.com. And if there's any subjects that you want to see me cover, I'd be happy to try to broach them. 9 times out of 10, I'm going to learn something new as well. So thanks again for joining me, and I look forward to seeing you next time. Bye.